Hello students, in our previous lecture we have discussed about the topic of the Rutherford's nuclear model of atom. Clear? So today we have to start with our next topic. Before going to the next topic, there are small topics that are given in your book, that is the atomic number and mass number. So already you are having that what is idea about the atomic number and the mass number, but once have a look again. Atomic number, that is the number of the protons in the nucleus of any atom. Means if this is the structure of any atom and in center we are having nuclei, total number of the positive charge that is present in the nucleus of any atom, that is known as the protons, that will going to define the atomic number. Clear? And same for the number of the electrons, that atomic number will be equal to the number of the protons and number of electrons, because in overall we are considering that how much positive charge is present in the atom. In equal proportions there will be negative charge in these shells that will going to present. Clear? Because overall we are saying that atom is the neutral in nature. Clear? And then next is the mass number. Mass number is the sum of the number of the protons and neutrons, that is the total mass of any atom is decided by its nuclei. Okay, so how many number of protons and neutral particles are present in the nuclei, that will going to decide the atomic mass of any atom. Clear? And the next topic, that is isobars and isotopes. Isobars having the same mass number and isotopes having the same atomic number. Example for isobars, you can see that carbon and nitrogen both are going to have carbon in its isotopic form. We are taking here that it will going to have atomic mass 14 and nitrogen also. And same for isotopes, you can see that same atomic number. For example, that is discussed here, that is for hydrogen we can take its isotopes, that prosium, deuterium and tritium, in which atomic number always going to be 1 and mass number will going to vary according to the number of the neutrons. Clear? That for prosium we are considering that it will going to have one proton only, there is no neutron. And for deuterium we are considering that there is the one neutron also exists in the atom, and one proton and one neutron will going to result in atomic mass equals to 2. And same for tritium, that it will going to have one proton in its nuclei and 2 neutrons, which are accountable for its atomic mass, that will be 3. Clear? So drawbacks of the Rutherford model we have already discussed. And the next topic, that is the developments leading to the Bohr's model of the atom. Historically, results observed from the studies that studies of the interaction of the radiation with the matter have provided immense information regarding the structure of the atoms and molecules. Clear? Means when we are considering that any kind of matter, this is any kind of matter. Clear? It will going to have small atoms present in it. When any radiation from any light source falling, radiations from any light source falling on its surface, then how the atoms and molecules of what the matter actually consists of will going to react. Clear? On basis of that we can define the structure of the atoms and molecules. Means ਜਦੋਂ ਆਪਣੇ ਕੋਲੇ ਕੋਈ ਵੀ ਰੇਡੀਏਸ਼ਨ ਮੈਟਰ ਦੇ ਨਾਲ ਇੰਟਰੈਕਟ ਕਰ ਰਹੀ ਹੈ, ਸਟਰਾਈਕ ਕਰ ਰਹੀ ਹੈ ਉਹਦੇ ਸਰਫੇਸ ਦੇ ਉੱਪਰ, ਠੀਕ ਹੈ, ਉਹਦੇ ਬੇਸਿਸ ਦੇ ਉੱਪਰ ਆਪਾਂ ਕੀ ਚੀਜ਼ ਡਿਫਾਈਨ ਕਰ ਸਕਦੇ ਹਾਂ, ਐਟਮ ਦੀ ਸਟਰਕਚਰ ਐਂਡ ਇਟਸ structure of the atom and molecules we can define. Clear? So Niels Bohr utilized these results to improve upon the model proposed by the Rutherford. एंड नील्स बोर ने इसे थ्योरी के उपर फर्दर किया वर्क करना स्टार्ट किया. ठीक है, जो थ्योरी पहला रदरफोर्ड ने दिती उन्होंने ही अगे की है मॉडिफाई किया गया. two developments played a major role in the formulation of the Bohr's model of the atom. So what are these developments? First development is regarding the dual character of the electromagnetic radiations, which means that radiations possesses both wave-like and particle-like properties. Clear? Means when we are talking that any radiation will going to have, for example, this is any kind of radiation, we are talking that this can have wave-like nature, means it can oscillate in the form of the wave, and we are also saying that it can have a particle-like nature, like that. Clear? So what is the difference between both? When we are talking about wave-like nature, means we are saying that energy of the light radiation is spread out in the space, in overall space equally. Clear? Energy is spread out in space. But when we are talking about particle nature, then we are saying that energy of the electron is deposited at a particular points. Clear? Here ਜਦੋਂ ਆਪਾਂ ਕੀ ਹੈ ਕਿਸੇ ਵੀ ਵੇਵ ਦੇ ਪਾਰਟੀਕਲ ਨੇਚਰ ਦੀ ਗੱਲ ਕਰ ਰਹੇ ਹਾਂ, then we are saying that energy is available in discreted units. Clear? So this is the basic difference between both wave-like and particle-like nature of electromagnetic radiations. So we can say that radiations can have a dual character, means can behave like a wave and also like a particle. So